All right, so in this video, we're going to extend our learning from area of polygons to now finding the area of polygons that has you work with trig. And so when we talk about trig, we're talking about using SOHCAHTOA in some of our situations. But there's a couple things that you need to know and understand how to find before we get to the step where we actually use our trig functions to either find, some missing sides or some missing angles. But of course, this all has to do with finding the area of a polygon. And so one of the skills that's important for you to have first is how to find something called a central angle. I guess I'll leave it underlined. So central angle. And the central angle essentially is another type of interior angle that exists on a regular polygon. This normally is what you're going to do is take 360 and you're going to divide that by the number of sides. So an example of this would be, let me draw something like a hexagon really quick. We'll pretend that this is regular, that all the sides are equal, even though it doesn't necessarily look like it. And let's make that larger. So let's do it this way. I'll have the central point right there. Remember, we did draw triangles when we were finding areas. So from central to vertices to each vertex before. And so 1, 2, 3, 4, 5, 6, right, also matches the sides of the hexagon. And so you're taking 360 divided by 6. And where the central angle is it would be this right here. Here's the central angle. Here's one. Here's one. Here's one. Here's one. And notice as I'm connecting all of them, they make a circle, right? And that's where we get the 360 from. So if I'm taking a full circle of these angles right here, then I'm just dividing it by how many angles there are, then I'll get the value of one angle. And so in this case, from the example below, it'd be 360 divided by 6, which would give me a central angle of 60 degrees. And so I can zoom in on this to kind of show you. That means this right here is 60, this is 60, right? We have 60 all around. And so those are the central angles, right? Central meaning it's in the middle, it's in the central area. And so you need to be able to find that first when it comes to finding areas of polygons with trig, because there's going to be instances where you are only given certain information. I can kind of extend this a little bit. So we'll keep looking at this problem, and now I'm going to draw a new line. And say I draw this line right here from the midpoint of that side all the way up to the center. And so remember that right there is called the apothem, and it also represents height for when we're trying to find the area of one of these triangles right here. Right, and so I need some information about that apothem there. Maybe I say that the worth is 10, and maybe someone throws a variable at me, and they say that the side length right here is worth X. And so now I'm left a little confused because I'm trying to find the entire area of this triangle, correct? But all I have is a central angle, I have the apothem, and then I have a variable, and I'm missing the side. I have no idea what the base would be, right, to find the area. And so what you could do from here, what I would recommend is take all this information right here and draw it separately. And so I'm going to go ahead and do that. And one thing I want you to notice that I didn't mention before is the apothem, when it cuts through here, it's perpendicular to the side length, meaning when this is drawn, it's perfectly cutting that in half. You're also creating a right angle here. Therefore, this triangle all the way here is a right triangle. And so let's draw this right triangle. Okay, it's a little crooked, but that's okay. All right, cool. So we have the variable of x right here. This is going to represent that apothem from earlier. So that has a value of 10. And then don't get mistaken and call this value right here 60 degrees. Because if we zoom in, right, this whole value right here, this whole thing is 60. If the apothem is going through the middle, it's bisecting this angle in half. So this angle, this part right here, that angle, does not represent 60, it actually represents half of it. And so half of that would be 30 degrees. And then of course, let me not forget the right angle that has been created there. And so now I have a right triangle. And if we just looked at this in general, we can think back to a different unit, right? When we were doing trig functions and we know how to find missing sides based off certain given information. And here we have a right triangle. I'm given a degree, I'm given an angle, I'm given a side, and I'm given a missing side. And so this is where we finally start using our trig. And I can think back to SOHCAHTOA. And I'm going to label some things, right? So across from my degree, I have my opposite. And then it looks like right next to I have an adjacent, meaning I'm going to use my tangent function. And so I'm going to set up that equation there. So that's going to be opposite over adjacent. Set that equal to, where this represents the tangent function. So tangent, and then we're going to use the degree measurement of 30 over 1. And so all you really have to do is multiply these together to find this missing side. And that won't be the end of the problem. It's going to be a longer process. So I'm going to go ahead and plug that into my calculator. I'm going to do tangent 30 times 10. And so the value of x is now 5.7. I'm going to round it to maybe the thousandths place. So let's call it 5.774. Okay. So all I've found right now is this side length right here. So if you look at that all the way back to this original problem, we're being asked to find this entire area. And so far, we haven't even focused on this whole triangle. We've only focused on half of that singular triangle. And so I'm going to go ahead and take this right here. Let me move it. And so it'd be nice if I can just take this right triangle and then I can just double it so I can get the whole area of that. But maybe I want to find the area of this first, and I can just go ahead and change that value to 5.774, and I'll find the area, which would be base times height divided by 2. So I'm going to take 10 times 5.774, divide that all by 2. So that's going to give me around 28.87. And this is just the area of half of a full triangle in that hexagon. And so what I can do with this to get the full triangle is I could take this area, aka 28.87, and I can double it. So I get the full value of a regular triangle. So let's go ahead and multiply this by 2. And so now I have an area of 57.74. Once again, this is the value of one mini triangle from the hexagon up above, up here. So that gave us this entire area. And then now I can go ahead and multiply by the rest. So we have a total of 1, 2, 3, 4, 5, 6 triangles. So I'm going to take that value, oops, my bad. I'm going to take that value of 57.74, and I'm now going to multiply it by 6 of those mini triangles. And so I have a total hexagon area of 346.44. Right, and that took a lot of steps, but once again, there's a lot of different things you need to do first. I'll walk you through again. We found the central angle first, and then we cut things in half into a right triangle. We had a missing side from that half of the mini triangle, drew it out, used our trig functions, right, of SOHCAHTOA to go and solve that problem, and then we doubled back up and we multiplied by how many triangles we had. And so before we end this video, let's go ahead and look at just one more problem. So let's go ahead and look at this problem. Okay, so we have 1, 2, 3, 4, 5, 6, 7. So it looks like we're dealing with a heptagon. Okay, so it has 7 sides. I know that means it has 7 mini triangles. But the goal is to find the entire area. And it looks like I'm only given some little information here. So it looks like I have an apothem of Z. It looks like I don't know what the base is on that mini right triangle, and I don't know what the degrees are either. But I do have the value of a full side. So if this is 16 right here, then this is 16. What I'm going to do is I'm going to take this and I'm going to redraw it first. So I'm going to redraw maybe the entire triangle first. So let's go ahead and do that. All right, there's the full triangle. So what I mean by that is that full triangle right there is what I drew. And now I'm going to add the other pieces that I have. So I have that line going through. My apothem is worth Z. I have a degree measurement of X right there at the top. And then it says that this is Y. And it's just this little portion right here. So don't get that confused. Actually, let me draw that better. Nope. Cool. So that's Y right there. Just that little half right there. And we have some extra info, and we know that the full base, right, the full base has a value of 16. And so it wants me to find this entire area. And the first thing that's going to help is to find the full triangle, right? But it looks like I only have some information about half of that mini triangle. And the first thing I can start asking myself is, wait, do I know the central angle of this shape? Right, so I need to find this full degree measurement right here. And so we have a heptagon, we have 7 sides, and then remember to find a central angle, we're going to do 360 divided by the sides. And in this case, the amount of sides is 7. So I'm going to take 360 divided by 7, and it looks like I have a value of 51 point. I'm going to round it to, let's just do the 10th place. So 51.4 degrees. And that is the value of this right here. If I want the value of X in just that little tiny right triangle, which I'll draw out now. Then what I'm going to do is I'm going to take this and cut it in half because it's just half of it. It's getting bisected right here. So I'm going to take 51.4 divided by 2. And so I'm going to get 25.7 degrees right up there in that little corner right here. And then it's helpful that they gave us the full side of 16. We know that this apothem cut everything in half, so that means this is a mid-segment, or this is a mid-segment of this entire thing. So I actually know what y is. It would just be half of 16. And so y is actually just 8. And I'll go ahead and draw that over here. So this is 8. And then the one piece of information I don't actually know is that apothem. I don't know the height. And so I'm still going to leave that as z right here. So now, moving from that information, I have a little right triangle I can work with. I can do SOHCAHTOA to find that missing apothem. And it looks like in this situation, I have the opposite, I have the adjacent. So we will be using the tangent function again, like we did in our other example. So opposite is 8, the adjacent is z. We have a tangent function of 25.7 over 1. And when you do solve this through, what you're going to end up doing is you will be taking, trying to think, we're going to take the value of 8. We're going to take 8 and we're going to divide it by tangent 25.7. So I'm not going to walk through all that algebra, but it is going to be 8 divided by tangent 25.7. And so z is going to be 16 point, let's call it 623. I'm going to go to thousands place there. So that was the apothem, aka the height. So now we have all the information we need. And what's nice is I already know the base of that full triangle. So we can actually just mess with the main triangle from earlier. So this is the full thing. And we know the apothem has a value of 16.623. And I know that the entire base has a value of 16. So there's my base, there's my height. Let's find the area of that. So base times height divided by 2. This full area of this entire triangle is going to be 265 points, let's call it 97. And this heptagon has 7 sides, aka 7 mini triangles. So I'm going to take this value and I'm going to multiply it by 7 to get my total area. So times 7 should get a value of 1,861.78. And that's that. Once again, it takes a lot of steps to do central angle, breaking up into your right triangle, SOHCAHTOA to find your either whatever missing side you have. So it could be your apothem, it might be the base. You might even be given the hypotenuse sometimes and have to find your apothem and your base. And then do what you've done in the past to find total area of one of those mini triangles. And then finally multiplying by how many mini triangles you have in your polygon to find your total area. All right, hope that was helpful.